Thanks for joining me, folks. Just a very, very brief introduction to myself. My name's Andy Wyatt. I've been with Source since the start of the year, but I've been in digital testing for about 8 years now. I've been in application development though for about 30 years. So yeah, lots of experience. I've worked all around the world. I've worked with some great people in some great countries. And as I say, I'm loving being at Source because we do some great things. We've got a fantastic code of ethics as well. So my presentation today, practicing safe SaaS. So you might learn some things today that hopefully you'll learn some things that you didn't previously know. There's a statistic I like to draw on, which says, okay, if people retain about a third of what you tell them in a presentation like this, then that's a good result. So I just want, if you go away and you return a third of what I speak about, then that's a result. And I hope I'm going to tell you something you hadn't previously considered. Now, when I first came into cloud testing, it kind of blew my mind. I was thinking, well, okay, I'm testing applications, I'm testing mobile apps, I'm testing web applications, but I'm doing it in the cloud. How can that possibly work? So, and it may well be, we get to the point where we know how these things work and we've kind of internalized it. We get to the point where we take it for granted, and then it's easy for people coming to this afresh to kind of, they're going through the same learning process that we had the benefit of going through months or years ago. So the kind of thing I'm trying to get over in this particular presentation is to answer some of those questions and some of the considerations about, okay, you understand testing, but how do you take that next step? How do you actually move it into the cloud? And more importantly, particularly in the financial sector and also actually in the healthcare sector, how do we retain safe? How do we remain safe? How do we kind of work within our security and our restrictions that we have for these things? So I've just got ahead of myself, and this guy here, that I have no idea this baby, so I found him on the internet, but basically there is a lot of confusion into this. So you need to test your applications. You're not sure where or how to do it. You probably can't scale on site. In fact, very few customers can. Should you use the cloud? Can I use the cloud? And if so, how do I use the cloud? So a question that you need to ask yourself, and this comes up sort of saying, okay, particularly for those smart customers, there's a lot of very smart people in this space, and they're more than capable of putting their own grid together. And it's one of those things that says, I say to them, well, okay, should you be doing that? Are you being paid to test? Are you being paid to develop? Are you being paid to maintain infrastructure and shovel them, plug pieces of kit together, or spin up virtual appliances in AWS or whatever? The answer is you're being paid to test, you're being paid to develop. So let us take the pain of the infrastructure and the plumbing away from you. What we're going to do with this particular presentation, it's going to help you to plot your way forward. It's going to help you to understand, okay, I want to do cloud testing. I'm working in my testing organization, or I'm working in my development organization, or my Scrum team, or however your organizations are actually structured. And you need to somehow permit your organization to use a cloud testing platform. So this means you're going to need to engage other personas, other people, other roles inside of your organization. So I'm going to just outline the typical type of persona who needs to know, who needs to be involved in this situation, and why. What are they going to be asking you? So if you can go to them kind of before the fact rather than after the fact and be knowledgeable about it, and you make them part of the solution rather than the problem, you're going to get them on board much more quickly. Okay then, so who needs to know? So, and I'm sure this is no kind of great revelation, but essentially it's your security people. It's people responsible for information security, it's security architects. If you are a team member as opposed to a team lead or a departmental manager, your management will need to know, because if you're potentially exposing your organization to an external risk, then they need to know that actually we're going to be opening this up. What can we do in order to actually eradicate that risk and be able to test securely and safely in the cloud environment? And I just got ahead of myself. I'm always doing this in my presentations, but essentially get them on board early. These are human beings. I'm sure, you might be like this yourself. I'm certainly very much the case of this. If somebody comes to you after the fact, after they've spent hours or days or even weeks spinning wheels unnecessarily when all they needed to do was ask, I personally find that very frustrating. They are there, security people are there to do a vital job, especially from the financial services sector. They are there to protect investors, they're there to protect customers, they're there to protect you as employees, and more importantly of all, they're there to protect their customers. And being a customer is at the center of everything we do at SAUCELABS, and this is reflected in our customer base. So say, make them feel part of the solution rather than the problem to be overcome. I have worked this way ever since I've been working with cloud platforms, and I have found it's just about treating people as people. If you include them early, they actually get on board and they actually can be more constructive typically. So what do they care about? What do they need to know? So it's fairly simple things. And again, this might seem obvious, so forgive me for pointing it out, but they're going to know, okay, what data will be leaving the intranet? So a big part of what I do is particularly talking to new large customers, is that we normally have to jump through lots of security hoops. We get huge security questionnaires, and I've just completed one for a large company over here that was, I don't know how many hundreds of pages long. It was literally 1,000 to 1,500 questions, all about security, very, very detailed. And most of those questions were actually completely irrelevant to us as a cloud testing platform, because the questionnaires were geared up towards, okay, I'm going to outsource my HR system, or I'm going to outsource this HR database, or this, customer database and processes that are going to run in the cloud. None of this is true for us. You're testing your applications. Okay, and I'm going to tell you what runs where later in the presentation. But for the security people, what they're cared about, okay, is data security. What data will be leaving the internet, leaving the intranet, sorry. If it is going to leave there, what artifacts are leaving and where is it going to be stored? Is it going to be stored securely? Are we going to expose our network to unnecessary risk? And then I use the term at the bottom there quite clearly, de facto adherence to industry-wide security standards. SAUCELABS is a global distributed platform. We've got data centers spanning 2 continents, the United States and Europe. We've got data centers in about 5 different cities across the 2 continents. And we have different levels of presence in those particular data centers. Now, one important thing to understand is we employ our own guys to look after our own infrastructure. That's very, very important. We're not using, as a resident in an external data center facility, we're not using the data center staff to actually police and manage the infrastructure. We use our own people for that. But, we have SOC 2 compliance in some data centers, but not others. But the ones where we don't have SOC 2 compliance, for those of you to whom that means something, we actually do adhere to the SOC 2 standards. We just don't have that accreditation, which is why I use the de facto phrase in there. Okay, test automation against cloud endpoints. So this is a very, very simple view as to where things work. So the simple view is you are a consumer, you have a test to run, and you need to access SAUCELABS via the internet. Quite simple. And that's the easiest way to understand that you're consuming a service in the internet. And I know you saw Laszlo's great demo earlier on, so I'm actually going to very quickly show you what this looks like, except I've just hit a very sensitive button there. And what I really wanted to do was hit play. There we go, it's playing now. Just a very simple video that what it looks like when you actually spin up a desktop browser test. So we're actually spinning up the virtual machine. You go to the website. In this instance, it was whatever was on the BBC website yesterday, and then you do your test. In this case, I'm navigating to the sport page. Don't know why I'm doing that as a Bolton Wanderers supporter, because we got relegated yesterday, but that's another subject. The point is, it's very, very easy. So from a consumer viewpoint, you have run something from inside of your network, you've gone over the internet and you've executed against the web browser, which is running inside of the SAUCELABS environment. So you've got your 2 locations, where you're executing from and the SAUCELABS endpoint. I've got another very, very quick video here as well, which I'm just going to hit play. So this is a real device test, but running from automation this time. So you can see I'm running from IntelliJ. So again, the test automation in this instance is running locally on my machine, and it's going over the internet. And what it has done, it's launched a real mobile device in this instance, our German data center in Berlin, our mobile device data center in Berlin, and it's executed the test. And it's a fun little test, because what this basically does, it updates the geolocation using the GPS coordinates of the device. And this is just simulating what happened on the device. So I'm playing the video back of this particular test, and it's basically the journey from my local railway station to my local Tesco superstore. Okay, it's not a financial test. I'm not moving funds. You see those kinds of tests all the time. So I just wanted to do something, again, just to illustrate the fact that you've got a piece of test automation running inside of your local network, and you're, in this instance, the execution endpoint, as I'm going to call it, the test itself is being run on the device via this dialogue of commands between your network and SAUCELABS. So the reality is, and this is the part I'm really getting to, there isn't one connection. There's lots of connections. And you as a consumer probably don't want to care about the complexity of all the different processes that are required for us to be able to have VMs available on demand, devices available on demand, one process that dispatches another process using this protocol and something that uses another protocol. It's mind-blowing, and this is why you use specialists in that particular area. So at the end of the day, if you know the high-level view, it's probably enough to actually give the specialist enough information that they can actually fill in some of the blanks themselves. So, and again, I like to simplify what you as a consumer of the platform is actually doing in terms of the dialogues. So I'm actually summarizing all these many different connection types to two different basically groups. There's what I call front end and back end. So essentially, you think about the front end, this is you interacting with the SAUCELABS user interface, you know, with the test manager, the portal that Laszlo showed in his demo earlier on. So you've got, you know, you need to authenticate yourself to it. This is where you're doing your user interaction when you're getting the hands on, or where the automation is running from. So you might be running from your laptop, you might be running from your Jenkins server or your TeamCity server. That dialogue into SAUCELABS is what I call the front end types of interaction. But very importantly, and possibly more importantly, is the back-end dialogue. So the back-end is the test appliance. And this might be the virtual machine that's hosting the desktop browser that you're testing in, or it might be the real device that you're running on. These devices, these appliances need to talk to your test servers. Now, there's lots of ways you can make those test servers available over the internet. And I'm going to talk about the different security regimes and products that we support in a moment. But essentially, that is a separate dialogue. So the appliance to your test servers is a separate dialogue. It's a separate link, a separate connection from your network to SAUCELABS. And I call those back-end types of connections. So this is the same information in a different way. I've just made the graphic look nicer. So you can see there, the front-end communication with the person sat at the laptop or your CI server talking to SAUCELABS. And then there's the SAUCELABS appliances talking to you or whatever's going on. Ideally in your data center. Again, when we talk to customers who've got existing on-premises grids or even sets of mobile devices that they're testing on, it can be a rat's nest of cables under a desk in a corner of the office somewhere that everybody chooses to ignore because it's just a nightmare to try and maintain and look after. You know, ideally, if you're doing anything at all, it should be running, as I say, inside of your data centers. So then, and some of this came up in the questions earlier on, my test services are inside of my company intranet. They're behind my company firewall. So how do we do this? So don't panic. There are multiple solutions. So the vast majority of SAUCELABS customers uses the Source Connect proxy. And there's a bit more detail about this shortly, but I'm just going to list these for now. If you need a slightly, I'm hesitant to use the term higher scale because Source Connect proxy scales every bit as much as the IPSEC VPN tunnel does. But IPSEC VPN tunnels are very well understood by network and security people, the site-to-site VPNs. And again, I've got some more information coming on about that shortly. IP. In SAUCELABS, we've basically got a voluntary code of contact that we're conduct that we're actually evolving in terms of, you know, uses of terminology which are considered to be inclusive or exclusive, and the term whitelisting and blacklisting and things like that are deemed to be kind of alienating. So we're trying to find a new sort of dialogue. So internally within SAUCELABS, we're going to begin to talk about whitelisting as allow listing, for example. So I'm going to refer to it as allow listing from here on in. It's a term that you more generically will have heard of as whitelisting. And then there's a different approach, and again, Matt talked about this. He touched on this in the keynote about the new source runner, source control, which is coming soon. And I've got a very quick video vignette of that running as well. So the Source Connect proxy. So essentially, this diagram summarizes what's going on. So what this is it's you download the Source Connect software to install on your network. So again, you can validate that. Your security guys can do an audit. They can do some testing to make sure they're happy that that is secure as a piece of software. And then you initiate it from your end, from inside of your network. This is very, very important. It's running from inside of your network, and then it's punching the hole out from your network to the appropriate appliances inside of SAUCELABS. It's a secure, encrypted connection. So I'm not going to say it's not hackable, but trust me, you need several supercomputers to be able to do that. It's very, very secure. It's very, very encrypted, and it's very, very scalable as a platform as well. So this opens up a secure tunnel to enable you to run your apps or your mobile websites against your test automation or your live session that's running locally. So you can run your scripts directly from your CI platform. As I said, the automation is running where you are, and it's just using the source platform as the execution endpoint for the appliances themselves. And it's persistent TLS connection. So this is one of those things we keep up to date with the necessary security accreditations, the certifications, etc., that you need to have a persistent secure connection. As I say, the majority of our customers use the Source Connect proxy very, very happily. They use it in lots of different ways. As I say, from a CI server, for example, we recommend using transient connection. So essentially they're spun up on demand. You create the tunnel, you run your CI test, and then at the end of the test, when the appliances are destroyed, the tunnels are also destroyed. No more connection. Or we've also got some customers who have long running connections for lots of reasons. You might want to have it long running. You might want to even have high availability, failover type capabilities, which we have built into that product. So we have those long running capabilities in there as well. So that's the Source Connect proxy. So this is just a very quick example. Again, I've recorded the video. I don't actually believe in giving into the demo gods. So I've actually loaded the odds in my favor by having little videos. So I've got running on my local machine here a very, very simple web page. It's just a one-page website running against, you can see their local host on port 8000. Now what I'm doing, I'm connecting my live testing session to my Source Connect proxy, and I'm starting up a web browser. So this is running inside of our EU data center, which for the desktop appliances is in Frankfurt. It's going to start that virtual machine. And I say for myself here in Manchester, where I live, my home office, I am now running as though I'm on localhost. So it's using the Source Connect proxy to actually allow me to access a service, which is essentially inside of my home firewall here. I'm actually also connected to the SAUCELABS VPN connection as well. So I've actually got double layers of security there. So that's running behind the firewall, and a very, very simple example of how that can work. Now, one of the beautiful examples, and I'm probably going to get ahead of myself here, of where Source Connect comes into its own is if you've got different network segments for different departments, because that means you can have different tunnels to those different network segments quite happily, as opposed to needing to have a solution that can talk to all those segments, which actually is not quite so secure and will give your security architects something of a nightmare. Okay, IPSEC VPN tunnel. So this is a very widely industry recognized solution for basically site-to-site VPNs. So these are the types of VPNs where if your office is in London and you've got a contract with Accenture or TCS or one of the other SIs in India somewhere, then you can actually, typically speaking, what happens is that you create a site-to-site VPN for the offshore employees to be able to be on the same network as the onshore employees. And actually, virtually every customer we now work with has an enterprise data center, like, for example, one of IBM's massive facilities in the Midlands in the UK, in Warwick, or you might be using the Google Cloud platform or something like that. The data, typically speaking, now is increasingly being stored remotely from where the people are. So again, you tend to have these IPSEC VPN tunnels, these site-to-site VPNs. This is no different. We are using the industry scalable IPSEC VPN solution, and actually, we don't actually mandate for you which IPSEC VPN product to use. Now that's more expensive and more complex for us because it means we've got to train our operator staff to be able to use different products. It would be much easier if we could say to you, okay, use this particular product. But again, because in this universe where SAUCELABS puts our customers first, puts them at the center of everything that we do. We're trying to make life as easy for you as possible, so we can use your choice of IPSEC VPN tunnel. And architecturally, it's very, very simple. So it's a secure tunnel that enables you to run your apps from your local test automation on the various appliances inside of SAUCELABS. And it's persistent it's not something that you'll bring down and up all the time. It's something that will be there and it will be running all the time. So IP allow listing. So that definition there, I've lifted more or less from Wikipedia. The practice of explicitly allowing some identified entities across or access to a particular privileged service, mobility, access, or recognition. So it's a very well-known concept, and essentially it's just about saying, okay, we're running these tests from inside of our network, and here is the IP address range of the SAUCELABS servers that we need access to. So your security folks can say, okay, if you're coming from these IP addresses, you can have access to these services. That's essentially what we're talking about here. It's inherently not quite so secure as the other two solutions, and it's actually more complex. I've actually been working with a customer for over 2 weeks now on trying to help them get their allow listing working. And it's all down to, I've tested their access and everything from our side. We know everything works and everything is set up correctly. The problem is exclusively down to the segment of the network that they're executing from being given the right privileges to be able to access the source servers. And it's just very, very difficult to set up. So we don't actually recommend that as a solution. And there's a paper, there's a link. In fact, I think let me move that one. There is a link to a white paper on the SAUCELABS website that tells you and discusses the various pros and cons of allow listing versus other techniques. Okay, so there's something else that you can do, and this is the source Testrunner toolkit. So this is something that's currently in development. I don't want to put a date in your head to say it's going to be released on X date, because that would be wrong, but we are getting this through the door as soon as we can do. And the reason I'm talking about this as another security option is because there are inevitably going to be some systems or subnets within your networks, particularly if you are a bank, that there's no way in my lifetime or your lifetime that those network segments are going to be exposed to an external service. But if you want to leverage a service like ours, how can you do that against services that you can't expose? The answer is to do something on premises. Well, you don't want to be setting up your own grid. That's just very, very expensive. So one of the things that you can do, and this thing that we're working on here is a source Testrunner toolkit. And essentially what it's doing is that the execution of the test is inside of, well, your execution is the same as it is normally, but running from your local test automation server. But the virtual desktops are running inside of Docker images. So and we're using technologies like Puppeteer and Playwright with Test Cafe and Cypress coming soon. Again, from a kind of alpha stroke beta viewpoint. So essentially the test will be running locally, and therefore it's inside of your network. So you don't need to open up any VPN of any nature whatsoever. The communication to source, there is a communication to source, and that is purely for the reporting. So, and it would be possible if you can't open up that network segment to be able to send up the reporting artifacts, you could possibly proxy that via a different route. We can talk about that, as and when. But essentially, you can use this as a means to provide a secure solution. Now, we're also going to support this inside of the source cloud. Of course, we are, because running lots and lots of Docker images, these tests execute incredibly quickly, but you're going to want to do tens, hundreds, possibly even thousands of them all in parallel, because this is about velocity and quality. This is about making sure you can run all of your tests in as short a space of time as possible with an infrastructure that can scale virtually infinitely. So we see the majority of our customers still running these inside of the source cloud, but because it's running inside of Docker, and one of the things it will be publishing as part of this product is going to be the Docker images containing the web browsers. Everything will be fully patched, everything will be secure. That's what we're providing, or one of the things that we're providing as part of this solution. So you can actually download it and run it locally as well. So that's a real big, departure from SAUCELABS from where we've been historically. So, we very recently pushed through our 3 billionth test on the platform since the company was started. I wouldn't be at all surprised when this platform goes live that we'll actually hit 4 billion in half the time it took us to get to 3 billion. So, what time will tell. I do have a short, very, very short demo. It's really quick, so don't blink because you might miss it. Literally, this is my test script. It's going to launch the Docker image, it's going to load the Chrome browser, and it's going to go to the source demo page, and it's going to validate that the title is SAUCELABS. Okay, so that's the script that it's running. So let me hit play. You can see there my command line there where I'm going to run it from, and I've got my source portal on the right hand side. So let me hit play. Okay, there's the container launched. The test is running. Okay, and it's worked already. So let's have a look. We're going to go to the test results, and you'll see the video playback. Okay, there's the video. I'm going to hit play. Blinking, you'll miss it. So you can just see, there he is. There's the source box. So that's really, in fact, it's so quick, that video. I'm actually going to play it again. There we go. Because it's so this is what we're talking about. This is, okay, it's a very, very simple, very, very noddy test. But this is the difference between these sorts of tests, for those of you that aren't familiar with technologies like Puppeteer and Playwright, is that when you talk about WebDriver, which is where SAUCELABS grew, essentially, you're talking about WebDriver commands being sent over the JSON wire protocol. So essentially, it's a very conversational dialogue. So you've got a piece of test automation, which is click this button. So then that's sent over the wire. The button is clicked and the results are passed back. And you've got this conversation that's going on all the time between your network and the source cloud. So there are ways, and some very smart ways, for example, with WebDriver IO, for example, and some of the JavaScript-based test frameworks where you can bundle up the number of commands so you minimize the number of these conversations, and that will make your test execution much, much faster. The difference between the WebDriver types of way of doing things and the Playwright way of doing things and the Puppeteer is the fact that everything is executing inside of the browser container. So you've not got this conversation going on. It's all executing inside of the browser container itself. So that's a major reason why it executes so much more quickly. Also, because it's running inside of the browser, it gives you a lower level of programmatic access to your website, the ability to maintain or access objects inside of your DOM. And because you're doing it at that kind of a level, this is one of the reasons why Cypress has become so popular, because the speed of execution is really, really quick. So as I say, and we will support Cypress with this particular platform, as I say, very, very shortly. So you can execute, as I say, a far wider range of tests far, far more quickly. Okay, moving on. And I've said some of this already. What runs where? Okay, so you've got your test automation, which is running in your intranet. You know, we do have customers, however, they've got their CI servers of choice running in the cloud. So for example, you know, they maybe have a Jenkins instance running in AWS, or they might be using Circle CI, which is cloud-based anyway, for example. So you've got your test automation that's running in the cloud. So that's where that particular piece of execution is. So it's on-premise in the cloud. And they're talking over the internet to the SAUCELABS browsers and the devices on the test. So you can see there, the test automation, the test services run wherever you as a consumer mandates it to run. But the browsers and the devices on the test run inside of the source facilities. I said that really, really quickly. If there's any confusion about that, please put that on the chat and we'll try and clarify that later. Additional security facts that I've not already spoken about. Again, Laszlo, I think, mentioned this in his session. At the end of your testing session, be it a live session or an automation session, the VMs are destroyed. There's no risk of any caching, cookies being stored, the next customer to use a spun up VM to see what you were doing on your website, you know, where it was left. None of that because can possibly happen because those VMs are destroyed at the end of the session. When it comes to real devices in our public cloud, inherently the public cloud is a shared device pool. So that means that when one customer is used it, the device is released back to the pool and the next customer can use it. So that sets off all sorts of warning bells, quite rightly, in the minds of our customers. And there's actually a great paper again, on the source website, that actually details what cleaning process we have between these sessions, but we do have a cleaning process. So the 32,000 foot view is if you're testing your app, the app is removed and any data that belongs to that app is removed. But we also remove any open browser tabs and we flush out any cookies and we delete the browser history. A couple of other small things we do as well, but essentially that's what we do. So there's no risk of leakage from one customer to the next. And if you do, in the unlikely event that you do come across a device which is got something preloaded, please raise that as a ticket with us so that we can look into that, because it possibly means that maybe something didn't close down properly. We do monitor this, but things do slip through sometimes. But as I say, that is the process for getting that done. So the cleaning process we run between sessions. So you get a close to session message. Again, this information, I've given the URL where the cleanup procedure is detailed for you. But essentially, browser's reset, no open sites left on the device, browser, everything I've just said, the browser history deleted. We don't factory reset public cloud devices because that is massively time consuming. And actually, you may not know this, if you factory reset a device too many times, they do become bricked. So for those of you that don't know the term bricked, it means useless. You can't interact with the device, you can't use the device anymore, and the best you can do is to use it to prop doors open with. I think that's one of the reasons why where the term bricked comes from. Okay, so we do this cleaning process. The device is then returned to the pool and it's made available for use by the next public cloud customer. Okay, so on the subject of mobile, again, thinking with your security head, most of the people on this call right now are financial services organizations. So public versus private devices, again, I'm introducing a new term there that I haven't done that previously. So the public cloud, again, it is what it says. It's a cloud, it's a pool of devices which any of our customers have got access to at any time, assuming the device, of course, is not already in use. But our enterprise customers, most of which are, say, in the financial services sector especially, have private devices. And they have private devices for lots of reasons. So I've given a very quick lookup table here. We've actually just published a new white paper actually on Real Device Cloud, the RDC as we call it, which goes into a bit more detail about public and private. But the high level facts I've just extracted here just to present to you today. So for public devices, you might need a key to get hold of that device. But if you've got a private device, you're not sharing it with any other customers. It's dedicated to you 24/7 by 52. So that device is yours all the time. Obviously, only one of your internal users can access the device at any one moment in time, but it's there, and it's dedicated to you. So if you, for example, have a concern about having an app, a pre-release app on the device, and just say, it's not removed from a device, so it can be then downloaded from a device and the APK reverse compiled to look at the source code. That's very, very difficult to do. You've got to be really knowledgeable about platforms to know how to do something like that. And actually, we don't permit that level of access to the devices anyway. So that's why you run a private device. You're not sharing it. They're very, very clean, very, very secure. We also give you the option to use SIM cards. So for hopefully obvious reasons, we don't have that option in the public cloud. The main reason being abuse. Customers kind of sending silly messages or making phone calls to strange destinations at our expense. That's why we can't do that. Whereas with SIM cards, you've got the options as a private device user to use SIM cards, which would be great for things like two-factor authentications or one-time passcodes, that kind of thing. You can do that kind of automation with devices with SIM cards, something you obviously can't do with an emulator or a simulated device, which is something else we offer within the SAUCELABS platform. There's a relatively recent development called virtual USB. So think of it as a very, very long USB cable. So if you can open up a device, if it's an Android device, it's running inside of our Berlin data center, for example. Maybe you're in Barcelona, so you've got a 1,000-mile or more long USB cable, but then you can open that inside of Android Studio and you can actually have an interactive debug session. So you can debug your native apps. You can also debug your Chrome, your web application and what it looks like and what the DOM objects and artifacts look like. You can debug the DOM again using virtual USB. Similarly, we have that capability for iOS. You know, you can debug an app that's been developed in Swift or Objective-C inside of Xcode, or you can debug your web application as it runs inside of Safari. And obviously Safari, well, I speak about that. Your ability to run your test across as wide a range of browsers as possible is invaluable, because, for example, the way that highly graphical organizations or highly graphical applications run, because of the rendering engine, excuse me, get some glass of water. The rendering engine inside of Safari can make your applications seem a little odd, potentially, which is one of the reasons why we're increasingly being asked by our customers what Safari support we have, which is why we run the desktop browsers. You've obviously got the ability to run Safari on our Mac farm. You've got the option, again, Financial Services Act apps, you might need access to the iOS keychain. So when you've produced an app and you've installed it, you need access to it. You don't want that keychain trust to be destroyed. So therefore, it means that you won't want to re-sign the app. So those of you that know nothing about iOS app development, you can kind of switch off for just a minute, because this is a complex subject. But essentially, if you have access to the keychain, if your app requires access to the keychain, then you can't re-sign the app in order for the app to then install on the device. So for private devices only, you can choose not to re-sign the apps as part of the app installation process. Whereas in the public cloud, apps are always re-signed using our global developer certificate that we have with Apple for all of our devices. So if you do need to re-sign the app, that would obviously therefore mean that we'd need to provide you with the UUID of the device so that you can actually add that to your list of approved devices with Apple, and we'll happily do that and help you to find out where the UUID is on those particular devices. We'll allow you to list additional apps. So there might be external apps, you know, so it might be there's a third-party app you need to install, so you can actually install that app, or apps, might be plural, to remain on those devices, because your test cases might require looping or in conversations between multiple apps. And then you can also with private devices, you can directly request a specific operating system upgrade on a specific device at a specific time. So whereas in the public cloud, yes, we do provide beta support for major and minor releases, but basically on a get what you give basis, because we need to maintain the balance of devices, device versions and operating systems in the public cloud. And then for private devices only, we support the use of the IPSEC VPN connection, which I spoke about earlier. One or two other things that you might want to consider: all the device screens are dimmed, so our operators and our data centers can't see what tests are running. It also means if another customer's interacting with the camera on a device, they can't see what's running on another device. So this is very, very important, you know, so these are things that you might not otherwise have thought about, but we have, it's our job. So we actually make the devices and using our device cloud even more secure. And as I mentioned a few minutes ago, we actually only employ our own operations staff. So we are entirely accountable for the entire operation of the data center. Okay, so that's enough about devices and appliances. And I've touched on some of this earlier on as well, but what about my data? So the data is never stored outside your network, okay? And that one fact normally makes the security architects calm down a whole load. You know, you should only be using test data anyway. And I'm saying that because I have come across some customers, actually not at SAUCELABS, but in previous lives, I've come across customers using cuts of production data in their testing. It's actually illegal in most countries. So you really shouldn't do that. It's a complete breach of GDPR. We can't recommend it. I can't recommend it with a consultant said. There are other ways. There's plenty of ways of getting good quality test data. Okay, but it's not stored in SAUCELABS. So from our viewpoint, all you're doing is executing your tests against our endpoints. So what is coming into SAUCELABS? You know, if you just think about it, maybe it's obvious. So for example, you've got to log into an application, say, so you're going to stream a user ID and you're going to stream a password over whatever connection protocol that you're using. So clearly that information is entering our network, but it's transient because once you've got past the logon screen, it's gone. You know, unless you've cached it inside of your app, of course, but that's something entirely different. So that the use of the test data to animate the test scripts is a completely transient thing. Okay, But any data that might be displayed on the web browser or the real device screen, because we record the video and you can capture the screenshots, that is where that data is captured. So therefore, there are various reporting artifacts that where that data might be captured. So that hopefully is fairly clear in terms of about the data. We're not, as I said earlier on, we're not storing your HR database inside of SAUCELABS. This isn't happening. So, and again, this question was asked earlier on. So again, I've summarized this for you very, very, simply. So what is stored inside of SAUCELABS and for how long? So videos, screenshots, and logs are stored on your portal for 30 days. And as Laszlo said in his presentation, if you choose to actually download all of those artifacts and delete them straight away via the REST API, then you can absolutely do that. So if you want to have a cleanup at the end of your test that does that, there's nothing stopping you from doing that as part of your automation, your CI process. The metadata, however, the test names, the operating systems, the browsers, the dates, and to all the metrics that are anonymized, we keep that data indefinitely. So, I mentioned a few minutes ago that we've performed over 3 billion tests have been performed on the SAUCELABS platform. That has given us a massive amount of insight into test automation, the performance of test automation, the reliability of test automation, the speed of test automation. All of this information is massive insight for us to be able to have a big data store and an understanding and an insight into how we need to evolve our platform moving forwards. So that metadata is vital to us, which is why we keep that data indefinitely. And you can then see your trends over more than just the 30 days. You can see your trends in over 12 months and over 2 years. You can look back and say, okay, how were we doing a year ago, and that kind of thing, because everybody's looking to continually improve. There's a concept of source storage, which is a secure encrypted area that's dedicated to you. Again, there's no risk that any other customer can get access to anything in that particular area. So this amounts to the APK and the IPA files for emulator and simulator testing, as well as the APK and the IPA files that you might have stored for what we call unified platform. I'll talk about that in just a minute. But there might be other artifacts. You might, for example, wanted to test the upload or download of a PDF on a desktop browser app or something like that. We keep these artifacts for 60 days. Just very, very briefly about unified platform. I'm sure that most of you are aware that SAUCELABS has grown organically over a period of years. So, a few years ago, we acquired the test object platform, which is our real device cloud. It's got its own user interface, and we're gradually folding that functionality into the SAUCELABS platform. We call internally the code name unified platform for that. We refer to it as RDC on source to our customers. So essentially that's something that we're working on as a high priority project, and we're expecting that to go live, as I say, in the coming month or two, hopefully, touch wood. But test object for now remains live. So any app that you upload to test object stays there indefinitely. So if you wanted to delete the APK and the IPA files that are in test object, because they remain there indefinitely, you would have to then manually go in there and delete them, or use the REST API to delete them. And then the user login metadata we also keep indefinitely. So hopefully that answers the question about what we store and for how long. Okay, what's worth telling you about in terms of remaining safe and secure that I've not already mentioned? And this might seem completely obvious, but again, I've seen this time and time again. Never hard code your access keys, your API keys, or your passwords in your automation code. I'm sorry if it sounds condescending, I don't intend it to be that. I've seen it so much that I just wanted to point it out. There's far better ways to do it. Use environment variables, use build tokens. So if you don't hard code that information, then that basically means your account's not going to get hacked. Enterprise customers also have the option of having single sign-on. So you might not even need your password to be able to access the source portal. Of course, your test automation will always use your source access key. So what does all this mean? I'm actually coming in ahead of time. But the summary is this: many organizations leverage cloud platforms for testing. So we regularly come across, yes, but we're a bank and we're different, therefore we can't use a cloud platform. And by the time we've gone through that particular loop of, okay, let's explore the reasons why, 9 times out of 10, if not 99 times out of 100, the realization dawns that actually, yes, you can, as a bank or a financial institution, test on a cloud platform. there are always going to be the exceptions, and I said that earlier in the presentation. Very, very good reasons. One of the banks we deal with here in the UK has got some very sensitive systems that connect to their bank HQ network and their branch network. There's no way those networks are ever going to be connected to the internet, as I say, not in my lifetime. And they've made that very, very clear, and that's their security policy. Okay, never say never, but they do need to test things in that particular environment. So there is a need for other testing approaches in that kind of a situation. But we can always find a solution for, okay, well, what can be tested in the cloud, and is there a way to actually do it? And this is where talking to your security architects is really important, because you can find a constructive way forward. Okay. Security is massively important. I'm not underestimating it. Security architects can be some of the most awkward people to deal with, but they do it for the right reasons. If you work with your security team and not against them, you're going to make a lot more progress. Involve them early in the process. As I say, it's a human nature thing. If you involve somebody and make them part of the solution, then it's a much more constructive way forward, as we've seen with wider issues in the world right now. Make intelligent use of secure connections. So you've got Source Connect, IPSEC VPN. I say try to avoid the allow listing if that's at all possible. And if you can, when you engage the security people, as I've tried to point out in this presentation, understanding what runs where and what information goes where and why, when you have these conversations, you will instantly appear a lot more knowledgeable to the security people. You're going to appear as though you've thought things through, and they're actually going to them with a genuine problem to solve, but you're giving them a lot more information for them to think creatively to help them solve that problem. And that is the key takeaway. If you're going to take away one thing from this presentation, it's that by giving these people the chance to do their job effectively, then you're going to be able to actually move into and leverage cloud testing platforms way more effectively. And if you've got any questions on this, and I'm sure you will have, and I'm sure your security people will have, we have our own security folks as well, world-class security people, I have to say. Ask. We're here to help you be successful in the SAUCELABS platform. And with that, I will say thank you very much for your attention. I'm Andy Wyatt, and that's my LinkedIn address if you want to know a bit more about me. But thank you very much. Open for questions.
In order to avoid any kind of prolonged, embarrassing silence, we got some, Teresa just putting some questions in there. I was actually going to start and ask questions of the other people that are on the call today as well, and find out whether, I know security has always been particularly strong in financial services, but whether people feel that there is any kind of change in how much more security conscious people in testing and QA need to be, or whether it's still around about the same kind of level. So it's more of a question not to the SAUCELABS people, but obviously to our guests on the call today. And feel free to drop your answers into the chat here on Zoom, or just to speak up. I'm just interested to hear from you guys on the phone or on the Zoom.
So to get it rolling, I mean, obviously just come off mute if you want to say something. But from my viewpoint, what I've seen, Matt, I've absolutely seen that people are way more security conscious than they ever have been. Quite necessarily so, because cloud technology is still emerging, and we need to be wary.
As you know, I spent most of my, before SAUCELABS, with a couple of years in a different industry. Most of my time was spent in cybersecurity. So Justin Dolly, who's our new CSO, I knew Justin before he came in here. And I can always remember when I used to talk to chief information security officers, one of their biggest challenges would be to say internally, we need to embed security in everything that we do. We need to put this into everything that we build, every process that we run, and so on. And I used to wonder, well, how is that possible? Because particularly CISOs don't often have big teams. They're just influencers or people that set policies. So, and I used to wonder whether it could ever really be achieved. But now I look at what QAs and developers are trying to do with how they build that in. I can actually see how that might work. So it's the first time I had sort of two completely different careers kind of join up like that. So, and I think that's a combination of people in this industry becoming more aware of the requirements of embedding and making sure the code that they write is secure, instead of the sort of retrofitting things by doing vulnerability assessments, and and often then discovering. But discovering something doesn't work in production is painful. Discovering something is a security flaw and provides access to information that it shouldn't do is a far, far different thing. So I feel like there is a kind of coming together of the security not the security drivers more than anything else, and the ability to make sure code is secure right from the very start. So
yeah, I mean, I think that there's a very famous transition. I can't remember who created it, but I think right now, as far as security in testing goes, we're at the conscious incompetence phase generally, globally. Because people know that there are issues, they don't necessarily know what they need to do to actually fix that. And I mean, there's some very, very scary metrics out there. I mean, there's something, I read a report recently that said about 80% of application code, so this is the application code, not the testing code, has been written using open source libraries. 80%. Right. So this is why companies like Sonatype, to actually test the veracity and the security and the safety of that code, are absolutely vital. And this is where what we're seeing in terms of the more mature customers now, who've moved beyond this conscious and competence side of the cycle, to actually say, okay, we're actually using technologies like Sonatype, things like that, to be able to say, is my code secure? Is my test automation code secure? So this is what's happening, and all these things are actually coalescing quite nicely, and that's definitely the next step of maturity.
And I wonder, I was thinking back to Guido and Waifina's presentation when they were talking about the teams that they had to involve. And I'm wondering, actually, because I've had this world in cyber as well as this world here, whether actually you could find some unusually strong and powerful sponsors or influencers in the security teams. If you're in if you're in testing, or you're in the DevOps tool chain, and you go early to the security teams to say, I want to make sure that we're embedding secure practices, secure build, and all of those kind of things that are important to them, you might actually find an unusually strong and influential sponsor in there who might help give you access to budget and funding for things as well.
Yeah, absolutely. As I say, it comes back to my main takeaway, which is the human being side of it. Just include people early, because that can also make sure you've got the right budget to test these things.
Yeah.
It's not just security, it's performance as well, because that's normally left till the end. So as much as this stuff that we can shift left as possible, that means it's cheaper to actually do in the long run. So people need to understand that and look at it from a holistic viewpoint.